To derive the sum of angles formula, we're going to use a visual proof, a geometric proof, which makes it fun and this makes the computation more easier. Okay, so we're going to draw a rectangle, and ultimately we're going to fit 4 right triangles into this rectangular space. Okay, so let's start by drawing the first right triangle. We'll start in the bottom left corner and just draw a right triangle. We're going to draw another right triangle that sits atop of that one. Okay, and this side has to be perpendicular to this line here. So we're making this one perpendicular, so it forms another right triangle. And then in this case, we have a right triangle in the upper right-hand corner. Now we're going to connect this point to the bottom left corner. Okay, so now we have established 4 right triangles. And just to be clear, there's a right angle. There's another right angle. We have another right angle here. And we have another right angle here. All right, cool. We're going to label this angle theta sub 1. We're going to label this angle theta sub 2. Okay, so we're going to sum these 2 angles. Now, knowing if we add these 2 angles, we know that this angle here has to be equal to the sum of theta 1 and theta 2, because they're opposite interior angles. Okay. So now we're set up. Okay, now using our sine and cosine functions, we know that this side of this inverted right triangle is equal to what? Well, that's just the cosine of theta 1 plus theta 2. So hence we're summing the angles, and this side is opposite, so this has to be the sine of theta 1 plus theta 2. We're going to call this side of this triangle R. That's just the length from this point to that point, the distance. That's also the hypotenuse of this triangle, which shares the same side as the inverted triangle. Okay? So knowing that this is the adjacent side of this right triangle, we know the length of this side of the triangle, which is R cosine theta 1, R times the cosine of theta 1. And the opposite side here is equal to R times the sine of theta 1. Now, since we're going to set R equal to 1, right, then this just becomes the cosine of theta 1, and this becomes the sine of theta 1. Also notice that the length of the base of this triangle here is the hypotenuse of this triangle here. Okay. So we could say that, okay, if we say this is R of 1, then this is equal to R of 2. So R cosine theta equals R of 2, except remember, we're setting r equal to 1. So that just goes to 1, and that just goes to 1. So r sub 2 is the hypotenuse, so we use that relationship to compute the sides, right? The length of the base and the height of this triangle here. Okay, so we say r sub 2, right? R sub 2 times, this is the adjacent side, so that's going to give us cosine of theta 2. And we know r sub 2 is equal to cosine of theta 1. So we can write that, substitute this in, cosine of theta 1, I'll put that in parentheses since I substituted it for r sub 2, times the cosine of theta 2. And we do the same thing for this side, okay? So we'll say r sub 2 times the sine of theta 2. And then we're going to substitute again for r sub 2 cosine of theta 1 times the sine of theta 2. All right, about halfway there. Okay. Now, since we know same reasoning, we have, let's look at the triangle in the upper right-hand corner, this one here. And let's assign its sines and cosines. So this being the hypotenuse, this is the magnitude of the hypotenuse of this triangle. So let's just call this the hypotenuse of the third triangle, r sub 3, okay? So since this side is, oh, we have to establish the one important fact. Say, well, how do we know what this angle is here? By geometric proof, we know that this angle is equal to theta sub 2. And I'll leave that for the viewing audience to work out, but you can prove that this angle equals this angle, because these are similar triangles, okay? These are similar triangles. Okay, so r sub 3, let's assign the magnitude of the sides now. So say r sub 3, right? This is the adjacent side here. So that's going to be assigned the cosine function. So we have r sub 3 times the cosine of theta 2, which is equal to, right, r sub 3 is equal to sine theta 1. So we'll substitute that in and then multiply it again by the cosine of theta 2. And we'll do a similar computation for this side, except this is the opposite side of theta sub 2. So this is r sub 3 times the sine of theta sub 2. And that equals sine of theta sub 1 times the sine of theta sub 2. And that does it. We have all of the components that we need to now derive the double angle formula for sine and cosine. We'll do sine first, the sine of theta 1 plus theta 2 first, okay? So we know that this side, since it's a rectangle, has to equal this side. These two sides are equal. And we have these two sections, the section of this triangle, the length of this side of this triangle, and we have the length of this side of this triangle. We know those lengths. So all we need to do is just add this length to this length as follows. So we're going to say that sine of theta 1 plus theta 2 equals this plus this. So let's write that. Again, sine of theta 1, I'm going to drop the parentheses, times the cosine of theta 2 plus the cosine of theta 1 times the sine of theta 2. If we subtract these two angles, all we have to do is just change the sign. And so we don't have to derive it again with the minus sign. We know that if we're subtracting theta sub 1 from theta sub 2, we just put an addition sign there. Right? Okay, let's go ahead and do the same for the cosine of theta 1 plus theta 2. Okay. So in this, we know that this is the magnitude or the length of cosine of theta 1 plus theta 2, but notice that we have this, it's not equal to the whole side. We have this section that we have to subtract, okay? So we know the length of this side, okay? So if we know the length of this side and we subtract, right, this part, this length, which is equal to, again, right, this part between here and here is equal to sine of theta 1 times sine of theta 2. So we can say that the cosine of theta 1 times the cosine of theta 2, which is the length of the bottom side, and we subtract the length again of this section here, minus sine of theta 1 times sine of theta 2. Okay, check, we have the identity or the angle sum identity. So when we add the cosine for the cosine of the sum of angle formula, we subtract these two terms. So if we put a subtraction sign there, we know that we add them. Okay. So these are referred to as, again, the sum of angles equation or formula. Okay. And this will give us our 6th and our 7th trig identities. Now note, we only use sine and cosine. If we know sine, we know the cosine. Okay. So therein, we've still just used 2 equations thus far. So in the next video, we're going to use the sum of angle formula to calculate the double angle formula. So stay tuned for that. More to come.